Hello, my name is Dan Hansen and I'm a Technical Marketing Manager with Cisco's Data Center Product Group. This video is part of a series that's intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Computing System, or UCS for short. This video will actually show methods that we use to host multiple security domains on a single UCS infrastructure. So we'll show this by showing a basic drawing of what we're going to demonstrate here in this video. We have two separate virtual, DMZs, and we have VLANs in one, certain set of VLANs in another, just showing, for example, VPC pairs in one or another. We show the port numbers that are used to attach to the individual DMZs on the infrastructure, and then the fabric downlinks that'll be used again for the purposes of this demonstration. And the idea is that wherever a service profile may live within the UCS infrastructure, if it adheres to our configured policies, then we have a restricted forwarding capability. Now, the fundamental part of this establishing security zones is we have a forwarding boundary. Now, this forwarding boundary is hardware enforced. It is done on ASICs within the UCS infrastructure. VLANs can live within this forwarding boundary or within this forwarding infrastructure. We're not doing this purely on VLAN tags, and forwarding can only happen within this boundary. This is not a per packet forwarding mechanism. We actually establish a priori before the fact packet flows through the infrastructure, and then packets are allowed to flow along those predefined links within the UCS fabric. And a given server adapter can belong to one and only one forwarding boundary within this infrastructure. So with that, we'll show how some of this actually looks on the infrastructure. So if we drill down inside of the user interface that attaches to the UCS manager, take a look at one of the fabrics, you'll see the various ports that I've configured as Ethernet. I can also dynamically configure some of these as storage if I wish. But on here, if I show port 7, you'll see it's a network-facing port, port 8 per the diagram, and port 20 also being network-facing ports on this infrastructure. And that's mirrored on both fabrics. When I drill down into one of the fabrics, you'll see the port channel that is configured with a pair of links on one set going into one DMZ, and the other uplink that is going into the peer DMZ north of this UCS infrastructure. So that's showing some of the basic connectivity. So when I go and take a look at the LAN uplinks manager, it's just a wizard that comes up and shows some of our connectivity. I'll resize some of this, but basically the idea is I take a look at the port channels, my various uplinks, and on the right I can draw your attention to the pin groups over there. So I can tell the system where I want the traffic to go by policy by setting pin groups. Now, these pin groups have to be subordinate to these forwarding domains. I can't create a pin group that crosses multiple domains. We'll show you what happens when we try to do that in a little bit. So for this example again, I go into my VLAN manager and you'll see the two separate uplinks into the two separate DMZs, and I have taken VLAN 300 here and I'll do it through 304 and say, add these to that network, that uplink. So the VLAN is being inserted into this L2 forwarding domain that is hardware enforced. A VLAN cannot exist across these forwarding domains. And you see that I've added them on the A fabric right now and mapped those VLANs into that uplink. And you can see some of my pre-existing networks that are out there too. And I select one of these, and just for an example, to be a native VLAN going off into that domain. And as you look, you'll see I have many other VLANs on this system that I've defined, both Fabric A, Fabric B, sending this group up a set of uplink interfaces. So we'll apply this, and it's actually removed those VLANs 300 to 304 off of any other uplinks. So I've pruned those VLANs now just to that individual uplink. As I look at the B fabric, you'll see I would do the same type of setup that we just showed on the A fabric. No difference, but we'll just move right along here. But you get the idea of making these mappings within the infrastructure. And again, we can see the pin groups. It's just those would have to be within these uplink domains within the UCS. So as we go on the server tab, the service profiles, you'll take a look, and we can drill down and we'll use for some examples on this video a Windows 2012 server. And if we go into the interfaces, the VIF forwarding path, you'll see the path through the system. But now we'll spend special attention on the FI uplink. So where this server is being presented into the real world. And again, this is independent of where this profile lands on the UCS infrastructure. All of that can be dynamic and virtual. We don't have rules inside the system. So in one example, in terms of forwarding paths, etc. So we'll go into the 2012 server here, and in one example, what I've done is I've brought up the various, shown the various network adapters that exist on the infrastructure. What I've done here is said, hey, I'm going to take one of those adapters. I want to add a VLAN in that other security domain into my server. Well, you'll see the system comes back with a source pin failure. And what that means is no traffic will be allowed to go off of that server on that adapter anymore, because what I've done is I've taken that, what I've labeled here as the ETH1 adapter, and I've made it require VLAN membership on both fabrics. Okay? And that's not going to be allowed because of this layer 2 forwarding boundary that's enforced. Again, it's not simply a VLAN forwarding mechanism, but this path that has been wired cannot be made whole. So I did this all with administrative rights. And we'll show the example now of, as an admin, I want to create policies. So I create a LAN connectivity policy in this example. I'll call it Apache Tomcat with a pair of Ethernets. They're using those DMZ VLANs. Now I could go and create a SAN policy also, and drill down in there, and you'll see I'm doing the same thing. Just find the vSANs and the fabrics that can talk on. So what I've done here, if you look on the bottom, is I've logged off and logged in as a user with just server admin rights, and I'm creating a service profile. Now what I want to show you is the case of, what if somebody says, well, that's fine, an adapter can only belong to one DMZ, but what about putting a server with multiple adapters or adding a new adapter? Here we're showing where, with the server admin rights, I can go into this profile and I can click on storage and select this connectivity policy, which is a whole I/O assembly, if you will, from the storage perspective. And on the network, again, I'm selecting a whole network I/O assembly that's been pre-configured for servers of this type. But nowhere can I add a new adapter to this server to jump outside of my security policy. And I can do the same thing on iSCSI adapters. So I have access to what administratively has been set up for this type of servers, or I could even template this for many groups of servers. And that is my connectivity policy that I'm allowed to get access to. Now this has been applied to Blade 5 on a chassis, and I'll just show some examples of you see the 6 Ethernets and 2 storage adapters that are defined. Now, what I really want to show here is if we log in as an administrator into the CLI for the UCS system, and I'm going to go connect into the adapter directly. Let's drill down onto the adapter and take a look at it from the adapter point of view. Because with UCS and the VIC capability, we actually are running a processor on the adapter to implement this policy that we push down from the UCS system. So on here you'll see it as its own MAC. We are talking from the UCS fabric down to the adapter, telling it how many adapters we want, the configuration of the adapters, the MAC addresses of the adapters, the types of storage, the WWNs of the storage, HBAs to be defining on the system. And all of that communication is over a private links, private FEX links that are gone into the adapter to the CPU, not exposed to the user space or the kernel space. And we stand up these adapters and the security policy behind all these adapters that the OS will see. So here we're seeing some of the adapters that are actually created. some of the capabilities on there. And you see the system QoS policy is even pushed down into the adapters in terms of sizing of MTUs, etc. So when we log back into the UCS system, this time again as admin to get a look into the system, we're going to show the capability next, which is another common idea, which is to take a look and do some Macforge activity. So on here, we'll take an adapter, and you'll see on this particular adapter, I'm sending a group of VLANs into the system, and I'm doing that for both ETH2 and 3. And this is an up and running server, so what I'll do is RDP into this. This is a Windows 2012 server. And I have these two adapters that are actually teamed, and I'm trunking multiple VLANs on that team of pair of adapters. And one of these that we'll look at is one that is my VLAN 6. So that is my 10.1.6 subnet. So if I go out, this is this first host, this is just a default router I'm hitting to get in here on my RDP session. But you'll see I can ping another host out on VLAN 6. And it's using, again, VLAN tag on that OS written VLAN tag in the infrastructure. So if I jump back to my UCS system and take a look at that network, you'll see that on that pair of adapters where I was sending all of these VLAN, the first test is, you know what, let's just say we disallow VLAN 6. Okay, so I'm going to cut that off on both of the adapters that are going into the fabric, both 2 and 3, which are members of this bonded pair. And we turn those off, you'll see these are actually being applied into that server, and those were put on the network side, so we don't have to reboot the server for this. And all of the same interfaces, the tagged interfaces, are still present on this OS, but when we try to hit that host again, you'll see this is actually not allowed. The adapter knows what VLANs it should be talking on, and it knows that no longer, that the OS sending a frame with this VLAN tag is not to be passed into the fabric. So this is taken care of. They cannot talk on VLANs, are not allowed. So as another part of this is a common VLAN hopping technique that have been out there is to rewrite these VLAN tags, on sent them on interfaces to switches that were configured to accept native VLANs only. So we'll run that test here real quick. If I jump into these same and just pick another VLAN, VLAN 4 here, and I'm going to configure those as native, save those. Again, nothing has to be rebooted for this case. And we jump back onto our samples, our test server, and try to talk out. You'll see that this one now is configured for a native VLAN, but regardless, the OS sending a tagged frame into the fabric, it still is only allowed to send this talk untagged on VLAN 4. It sees that a frame with a VLAN 6 tag comes in, and it does not allow it to pass. So the security policy has been pushed all the way to the interface between the adapter and the kernel. So another example we'll show here, and this is nothing to do with virtualization outside of I'm using a VM to emulate the crafting of a Mac to send out on the adapter card. So in this particular case, this is a host with a Nexus 1000 switch, and I will be using a host that is on my VLAN 6 that is, I'll just call it the 6.50 host. And I have a pair of uplinks that are actually going into the UCS fabric, one on each side. So on here, we'll take a look at that host. I'll drill into the service profile of the server hosting this. You can see the host is the .12. And I have a pair of adapters. Now, if you look at the adapter here, you'll see the set of VLANs that I'm passing into the host. And I have a network policy applied to both of these hosts. And this network control policy that we have, we'll show the definition here, it's set to allow Mac forgeries. So I can allow Macs other than the what the service profile is set on the adapter to communicate. So from my local host here, I just ping that VM and everything comes up. Now, if I go back to the set that to deny the Mac security, and I want to apply the profile, you'll see in this particular case, as I look at that server, and I can see that the burned in, the 0F and 0E Macs in this case are there, and I bring this back up, and you'll see that I can no longer ping out into the world. And the reason here again is that the system does not allow a source MAC other than what our policy is set for. So go back, reset this to an allow policy. On here, it's the standard message. This action actually does not even require a server reboot because we're doing this on the network policy. We bring this back up, start the ping again, and we can again send traffic from a MAC other than what we've administratively defined. To recap, hosting multiple security domains inside of a legacy infrastructure, whether it be rack or blade based, with dedicated I/O modules, MES cards, cabling rules, dedicated switches within a rack, all of that leads to a more complex environment, imposing state on the infrastructure. Within UCS, we allow these multiple security domains to be programmatically defined all the way through and including the edges of your storage network and the data network. This ends this UCS Advantage video, where we show how unique capabilities in the Cisco UCS can lead to simplified deployment models with much faster service turnaround to meet the increasing demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown in this video. Thank you.